PolyAPI Use Case, Partner Enablement by Darko Vukovic, CEO, PolyAPI, February 28, 2025. Service development for enterprises involves creating new services, typically built on top of existing software as a service and internal operational applications to enable new sales channels, partnerships, or product offerings. This approach allows businesses to design and build new purpose-built APIs that are entirely under their control, rather than conforming to external system requirements as seen with workflow automation. For instance, a hotel might build a guest app, an e-commerce retailer could develop a custom shop, or a food and beverage company might create a unique ordering and loyalty app. Although the front-end application is developed using different technology, it is part of the same overall project that leverages back-end innovations. A middleware platform like PolyAPI plays a crucial role in this ecosystem by managing the complex back-end tasks. It handles transformation, orchestration, authentication, authorization, and the scoping down of interfaces, allowing the client developer to work with clear, purpose-built APIs tailored to their specific needs. This focus on the back end ensures faster deployment, reduced maintenance costs, and greater operational visibility. By standardizing the development process and simplifying intricate back-end functions, enterprises can innovate more efficiently while keeping development teams aligned and agile. Key objectives. Every business has unique circumstances, and depending on your initiatives, there may be varying drivers for developing new services using a platform like PolyAPI. However, these are the ones we most typically see. New end user experiences. Develop custom solutions that replace default offerings, such as tailored e-commerce platforms, guest apps for resorts, loyalty systems, booking engines using partner rewards, or AI-driven customer support to deliver distinctive and engaging experiences. New partnership channels. Enable integration with distribution partners and vendors by exposing reusable APIs that span multiple systems or offer a subset of core functionalities, allowing seamless self-service integration. Accelerate time to market. Streamline the development process with a robust runtime environment and effective developer tooling so teams can rapidly build, iterate, and deploy new services without compromising on quality or security. Standardized operations. Consolidate service development and maintenance with a unified approach that maintains flexibility in language and library choices while ensuring consistent operations and reducing inefficiencies. If one or more of these objectives resonate with you, keep reading to learn how Poly can help. How PolyAPI helps. PolyAPI simplifies service development by offering 3 integrated components that work together to streamline enterprise operations and enhance IT workflows. By combining microservices, a flexible gateway, and a comprehensive SDK, PolyAPI enables developers to build and operate new services with ease. Here's a high-level diagram illustrating these capabilities. The first component, microservices, consists of containers that run your code as server functions. These functions operate in a serverless environment managed by Knative in our Kubernetes clusters, ensuring that your code scales efficiently and reliably. Written in languages such as TypeScript, Python, or Java, with plans to support C# in the future, these functions allow you to implement business logic in a modern, agile way. In addition, you have the freedom to integrate our generated SDK with any native libraries you prefer, giving you a robust development environment tailored to your enterprise needs. The gateway plays a dual role in managing both inbound and outbound traffic, leveraging distinct capabilities based on the context. For inbound requests, the gateway exposes HTTP endpoints and routes traffic through dedicated and reusable security functions that handle authentication and authorization. This security pipeline ensures that each request is validated to your specific standards before it reaches your server function, adding an extra layer of protection. For outbound traffic, the gateway facilitates seamless connections between your server functions and external systems. It automatically injects credentials where instructed, logs every call for enhanced observability, and emits error events that can trigger alerts, diagnostics, or incident responses, ensuring that any issues are quickly detected and resolved. The SDK completes the PolyAPI offering by providing a rich set of operations that enable your server functions to interact efficiently with underlying systems. It offers an extensive library of API calls, utility functions, and mechanisms to inject variables and credentials safely. This integration not only simplifies the process of handling errors and system communications, but also enhances the overall security and traceability of your operations. With these capabilities, developers can focus more on crafting the business logic, while PolyAPI handles the complexities of system interactions and security management. While developing the microservices and using the SDKs, all the same benefits that are detailed in our partner enablement use case are made available to the developers creating the microservices. If interested in how Poly's development tools make developers productive, give that article a read. Below, we outline the key features of each component and the value they bring to enterprise development and IT teams. Microservices, server functions. Server functions are supported with these capabilities. Language support. Develop server functions using TypeScript, Python, or Java, leveraging all native libraries and language capabilities. Interface schemas. Model request and response objects directly in your functions or by referencing external schemas, with full support for robust typing. Variables. Externalize and manage variables via the management UI or API. This enables microservices to dynamically retrieve mappings, indexes, objects, models, and more at runtime, adapting as they evolve. Client functions. Create and deploy reusable code blocks that can be integrated across multiple server functions or utilized by client developers. A typical use case is a generic mapping function that prevents the need to duplicate mapping logic in each server function. AI services. Configure server functions as AI services without writing code. Define service capabilities and interfaces, letting Poly and AI models handle the execution. Read more. IDEs. Use any IDE you prefer, enjoying native support for all your favorite extensions, tools, and configurations. Local and automated testing. Leverage your favorite local testing frameworks and automated testing solutions, along with built-in debugging features like breakpoints. Deployment. Deploy functions via the CLI, either directly by developers or integrated into your CI/CD pipeline for streamlined releases. Read more about Glide, catalog and management service. Automatically catalog server functions upon deployment. View production source code, associated types, and logs through a user-friendly management UI. Read more about it in the Partner Enablement write-up. Execution console. Execute server functions directly from the management UI using the execution console, where you can input arguments or reference variables for testing and manual retries. Logs. Utilize standard logging per language, e.g. log, warn, error. Logs are time-stamped, include unique execution IDs, and are accessible via the UI or API. Scalability. Built on Knative and Kubernetes, server functions scale dynamically by adding replicas based on demand. Sleep mode. By default, functions will enter sleep mode when idle, unless set to always on with a minimum replica count, optimizing resource usage and reducing costs. Cloud provider optionality. Maintain consistent development and deployment across various cloud providers, making it easy to port or develop against multiple platforms. Gateway, inbound and outbound. The gateway service is the central execution and event management layer, providing a unified interface for all API and server function interactions. PolyAPI or any other gateway can be used to expose server functions. API endpoints. Create new endpoints with unique URLs and methods to expose server functions. Execute endpoints. Execute the API endpoint to test the full flow, from receiving the request at the gateway, routing to the server function, handling orchestration, and returning the response. Execution time is tracked for performance testing. Execution IDs. The gateway assigns a unique execution ID for each request, which is tracked throughout the flow in metrics, logs, and returned to the client. Security functions. Configure the gateway to route requests to one or more specialized security functions for authentication, authorization, and validation. These functions receive the full request and return a Boolean to determine if the request should proceed, while also setting a rejection status code and error message if needed. Variable and secret injection. The outbound gateway can inject variables and credentials as underlying services are called from within a server function. Triggers. Define which inbound requests should trigger specific server functions. Triggers can be set to wait for a response, synchronous, or operate asynchronously, allowing processing to continue while confirming receipt to the client. Metrics. Associate execution times with each step of the process for debugging and performance analysis. Metrics are linked to the execution ID for detailed tracking. Scalability. The gateway, deployed as a Kubernetes service, scales based on the overall system load. SDK and AI assistance. The SDK and AI assistance capabilities, detailed in the Partner Enablement section, support server function developers in creating and maintaining their functions. Once deployed, a server function is automatically incorporated into generated SDKs, making it readily available for consumption by other server functions, regardless of their implementation language or client developers with the appropriate permissions. This seamless integration simplifies collaboration and enhances overall system interoperability. How Poly is different from the market alternatives. Poly takes a fundamentally different approach from integration platform as a service vendors and is much more aligned to the approach taken by serverless providers. Function-centric approach. Everything in Poly is function-oriented. Microservices are server functions. Underlying APIs are API functions. Webhooks, inbound APIs are modeled as asynchronous callback functions, and variables are accessible via functions. This unified approach enables seamless interoperability and aligns closely with native language development practices. Serverless architecture. Server functions run serverlessly and are managed through Knative. This serverless model is a key source of runtime efficiency compared to legacy systems that rely on dedicated compute resources. Native alignment with development practices. All components in Poly run natively on developers' local machines, within client applications, as dedicated servers, or as serverless functions. This ensures that most of your work can easily transition to a different runtime environment if needed. On-demand SDK generation. SDKs are generated on demand, including automatically within server functions. This dynamic generation enables updates to a single client function to propagate seamlessly across all dependent server functions. Designed for multi-tenancy. By leveraging computed property names, Poly allows different mappings or implementations per customer using a single server function. This flexibility significantly reduces code duplication and maintenance overhead when handling multiple tenants. Native Vault integration. Credentials and secrets are securely stored in our vault and accessed without exposing them to developers or server functions. This integration minimizes risks such as accidental logging or credential compromise in the event of a breach. Security functions. Instead of providing out-of-the-box policies, Poly allows you to write custom enforcement logic. This flexibility ensures that your security measures precisely match your specific needs without being confined to a predefined set of policies. Unified gateway for API calls. All API requests are routed through a centralized gateway, offering full visibility, reliable event delivery to clients, and the flexibility to update server-side function without requiring SDK upgrades. Kubernetes, native, and cloud agnostic. Poly is built to run natively on Kubernetes, making it fully self-hostable on major cloud platforms like AWS, Azure, or GCP. This design guarantees scalability, high availability, and flexible deployment options. Try it today. PolyAPI empowers enterprises to reimagine service development by transforming backend complexity into a streamlined, developer-friendly process. The platform integrates purpose-built microservices, a centralized gateway for secure API calls, and an intelligent SDK with seamless AI assistance, designed to support multiple languages, including TypeScript, Python, Java, and soon C#, and built on a Kubernetes native architecture. PolyAPI ensures scalable, agile deployments across AWS, Azure, or GCP. This comprehensive, function-centric approach not only accelerates time to market, but also simplifies operations, making it an ideal solution for businesses looking to create custom end-user experiences and new partnership channels. Ready to transform your API integration and service development journey? Reach out. Email us at hello@polyapi.io.